To ground and bond manhole covers and their metal rims, firstly gather the required materials. These include a copper ground rod, a minimum of 8 feet long and 5/8 inch in diameter, a copper or bronze ground clamp, a grounding conductor which is a minimum #6 AWG copper wire, a conduit body and its cover, concrete anchor bolts, a bonding jumper, also a minimum #6 AWG copper wire, and anti-corrosion compound. Step 1 involves driving the ground rod. Dig a hole at least 8 feet deep near the manhole opening. Insert the ground rod into the hole and drive it into the ground using a sledgehammer or a power driver. Step 2 involves clamping the ground rod. Use a ground clamp to connect the grounding conductor to the ground rod. Tighten the bolts securely to ensure a good electrical connection. Step 3 involves installing the conduit body. Mount the conduit body on the concrete near the manhole opening using anchor bolts. Ensure it is securely fastened to provide a stable connection point. Step 4 involves connecting the grounding conductor. Run the grounding conductor from the ground rod to the conduit body. Use a compression fitting to connect the conductor to the conduit body, ensuring a tight and secure connection. Step 5 involves preparing the manhole cover. Place the manhole cover on the opening. Drill a hole through the manhole cover and the metal rim. This hole will be used to connect the bonding jumper. Step 6 involves installing the bonding jumper. Cut a bonding jumper to a length that allows it to connect the manhole cover to the grounding conductor in the conduit body. Insert the bonding jumper through the hole in the manhole cover and the metal rim, ensuring it makes good contact with both the cover and the rim. Step 7 involves tightening the connections. Tighten the bonding jumper connections securely using nuts or bolts. Apply anti-corrosion compound to the connections to prevent corrosion, which can degrade the electrical connection over time. Step 8 involves covering and sealing. Install the conduit body cover to protect the grounding conductor connection. Seal all openings with concrete sealant to prevent moisture ingress, which can also cause corrosion and compromise the integrity of the grounding system. Additional considerations are important for maintaining the safety and effectiveness of the grounding and bonding system. If the manhole cover is located in an area with high foot traffic, consider installing a plastic cover for added safety. This can help to prevent accidental contact with the metal cover, especially during electrical faults. The bonding jumper should be protected from mechanical damage by enclosing it in a conduit or trench. This will prevent it from being accidentally cut or damaged, which could compromise the grounding system. Periodically inspect the grounding and bonding system for damage or corrosion and make repairs as necessary. Regular inspections can help to identify and address any potential problems before they become a safety hazard. The purpose of grounding and bonding is to create an equipotential plane, minimizing voltage differences and preventing dangerous touch potentials. This ensures that in the event of an electrical fault, the current will safely flow to ground, reducing the risk of electric shock. The grounding conductor should be sized according to the requirements of the National Electrical Code, NEC, to ensure it can safely carry fault current. The size of the grounding conductor is determined by the size of the ungrounded conductors that supply the electrical system. Refer to NEC Table 250.102 for sizing information. The bonding jumper should also be sized according to the NEC to ensure it can effectively bond the manhole cover and metal rim. The size of the bonding jumper is determined by the size of the equipment grounding conductor. Refer to NEC Table 250.122 for sizing information. When driving the ground rod, ensure that it is installed below the frost line to prevent it from being heaved out of the ground by frost. The depth of the frost line varies depending on the location. In areas with high soil resistivity, it may be necessary to install multiple ground rods to achieve the required grounding resistance. The grounding resistance should be measured using a ground resistance tester to ensure that it meets the requirements of the NEC. When connecting the grounding conductor to the ground rod and the conduit body, use listed connectors that are suitable for direct burial. These connectors are designed to withstand the corrosive effects of the soil. When installing the conduit body, ensure that it is securely mounted to the concrete and that all openings are properly sealed to prevent moisture ingress. The conduit body should be made of a non-corrosive material such as PVC or stainless steel. When drilling the hole through the manhole cover and the metal rim, be careful not to damage any underground utilities. Before drilling, contact the local utility companies to locate any buried cables or pipes. When installing the bonding jumper, ensure that it is routed in a way that prevents it from being snagged or damaged. The bonding jumper should be installed in a protected location, such as inside a conduit or trench. When tightening the connections, use a torque wrench to ensure that the connections are tightened to the proper torque. Over-tightening can damage the connections, while under-tightening can result in a loose connection. When applying anti-corrosion compound, use a compound that is specifically designed for electrical connections. The compound should be applied to all bare metal surfaces to prevent corrosion. When sealing the openings with concrete sealant, use a sealant that is compatible with the materials being sealed. The sealant should be applied in a continuous beat to prevent moisture ingress. If the manhole cover is located in an area with vehicular traffic, consider installing a traffic-rated cover. This will prevent the cover from being damaged by vehicles. If the manhole cover is located in an area with heavy pedestrian traffic, consider installing a slip-resistant cover. This will prevent pedestrians from slipping and falling on the cover. If the manhole cover is located in an area with a high water table, consider installing a waterproof cover. This will prevent water from entering the manhole. The grounding and bonding system should be inspected at least annually to ensure that it is in good working order. The inspection should include a visual inspection of all components and a measurement of the grounding resistance. Any damaged or corroded components should be replaced immediately. The grounding and bonding system should be tested after any repairs or modifications are made to the electrical system. The testing should be performed by a qualified electrician. The results of the inspection and testing should be documented and kept on file. This documentation will be helpful in tracking the performance of the grounding and bonding system over time. It is important to follow all applicable codes and standards when grounding and bonding manhole covers and metal rims. The NEC provides detailed requirements for grounding and bonding electrical systems. Local codes may also have additional requirements. It is also important to use qualified personnel to install and maintain the grounding and bonding system. A qualified electrician will have the knowledge and experience to ensure that the system is installed correctly and safely. Grounding and bonding are essential safety measures that help to protect people from electric shock. By following the proper procedures, you can ensure that manhole covers and metal rims are properly grounded and bonded, reducing the risk of electrical hazards. Equipotential bonding is another important concept related to grounding. It involves connecting all metallic parts of a system to the same electrical potential to minimize voltage differences. In the context of manhole covers, equipotential bonding ensures that the cover, the surrounding metal rim, and any nearby metallic structures are at the same potential, preventing dangerous touch potentials in the event of a fault. To achieve equipotential bonding, additional bonding jumpers may be required to connect the manhole cover and rim to other nearby metallic structures such as underground pipes or conduits. These bonding jumpers should be sized and installed according to the NEC requirements. Regular inspections of the equipotential bonding system are also important to ensure that all connections are tight and free from corrosion. The use of anti-corrosion compound on all connections is highly recommended to prevent degradation of the bonding system over time. In addition to grounding and bonding, it is also important to consider other safety measures to protect workers and the public from electrical hazards. These measures may include the use of insulated tools and equipment, the implementation of lockout/tagout procedures, and the provision of adequate training for workers. The lockout/tagout procedures are designed to prevent accidental energization of electrical equipment during maintenance or repair. These procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to prevent it from being turned on. Workers should also be trained to recognize and avoid electrical hazards. This training should include information on the dangers of electricity, the proper use of safety equipment, and the procedures for responding to electrical emergencies. The specific requirements for grounding and bonding manhole covers and metal rims may vary depending on the location and the type of electrical system involved. It is important to consult with a qualified electrical engineer or inspector to determine the appropriate grounding and bonding methods for a particular application. In some cases, it may be necessary to install a dedicated grounding electrode system specifically for the manhole cover and rim. This system may consist of one or more ground rods, ground plates, or other approved grounding electrodes. The grounding electrode system should be installed according to the NEC requirements and should be tested to ensure that it provides adequate grounding protection. The use of exothermic welding is another option for connecting grounding conductors and bonding jumpers. Exothermic welding creates a permanent low-resistance connection that is highly resistant to corrosion. This method is often used for critical grounding connections such as those in substations and power plants. However, it can also be used for grounding manhole covers and metal rims, especially in areas with high corrosion potential. When using exothermic welding, it is important to follow the manufacturer's instructions carefully and to use the proper equipment and materials. The welding should be performed by a qualified technician who has been trained in the proper techniques. In addition to the NEC, other standards and guidelines may also provide information on grounding and bonding. These may include standards from organizations such as the Institute of Electrical and Electronics Engineers, IEE, and the National Fire Protection Association, NFPA. These standards can provide additional guidance on topics such as grounding system design, testing, and maintenance. It is important to stay up to date on the latest curves and standards to ensure that the grounding and bonding system is in compliance with all applicable requirements. The information provided here is intended for general guidance only and should not be considered a substitute for professional engineering advice. A qualified electrical engineer should be consulted for the design and installation of any grounding and bonding system. Grounding systems, including those for manhole covers, are designed to provide a low impedance path for fault currents to return to the source. This helps to quickly trip circuit breakers or fuses, energizing the circuit and preventing electrical shock hazards. The impedance of the grounding system is affected by several factors, including the length and size of the grounding conductors, the type of connections used, and the soil resistivity. High soil resistivity can significantly increase the impedance of the grounding system, making it less effective. In areas with high soil resistivity, it may be necessary to use ground-enhancing materials to improve the conductivity of the soil. Ground-enhancing materials are typically composed of chemicals that increase the moisture content and reduce the resistance of the soil. These materials should be used with caution, as some may be corrosive or environmentally harmful. It is important to select a ground-enhancing material that is compatible with the soil conditions and that meets all applicable environmental regulations. The use of concrete-encased electrodes, also known as UFO grounds, is another option for improving the grounding system. A concrete-encased electrode consists of a bare copper conductor that is encased in concrete. The concrete provides a large surface area for contact with the soil, which helps to reduce the grounding resistance. Concrete-encased electrodes are often used in new construction, as they can be easily installed during the foundation pouring process. However, they can also be installed in existing structures by excavating around the foundation and encasing the conductor in concrete. Surge protection is another important consideration for electrical systems. Surge protective devices, SPDs, are designed to protect equipment from voltage surges caused by lightning strikes or other transient events. SPD should be installed at the service entrance and at other critical locations throughout the electrical system. The effectiveness of SPD depends on the quality of the grounding system. A good grounding system provides a low impedance path for surge currents to flow to ground, which helps to protect equipment from damage. When installing SPD, it is important to follow the manufacturer's instructions and to use the proper grounding connections. The grounding conductors for SPD should be as short and straight as possible to minimize impedance. Regular testing of SPD is also important to ensure that they are functioning properly. SPD can degrade over time due to repeated exposure to surge currents. Therefore, it is important to replace SPD periodically to maintain adequate surge protection. The use of isolated grounding is another technique that can be used to reduce electrical noise in sensitive electronic equipment. Isolated grounding involves separating the grounding conductors for sensitive equipment from the grounding conductors for other equipment. This prevents noise currents from flowing through the grounding conductors and interfering with the operation of the sensitive equipment. Isolated grounding should only be used in accordance with the NEC requirements. It is important to ensure that the isolated grounding system is properly installed and maintained to prevent safety hazards. The NEC provides detailed requirements for grounding and bonding in Chapter 250. This chapter covers topics such as grounding electrode systems, grounding conductors, equipment grounding, and bonding. It is important to be familiar with the requirements of Chapter 250 when designing and installing electrical systems. The NEC is updated every 3 years, so it is important to stay up to date on the latest revisions. The use of qualified personnel is essential for the safe and effective installation and maintenance of electrical systems. Qualified electricians and engineers have the knowledge and experience to design, install, and maintain electrical systems in accordance with all applicable codes and standards. They can also identify and correct potential hazards before they cause accident. When hiring an electrician or engineer, it is important to verify their qualifications and experience. Ask for references and check their licensing status. It is also important to communicate clearly with the electrician or engineer about your expectations and requirements. The safe and reliable operation of electrical systems depends on proper grounding and bonding. By following the guidelines outlined here and by consulting with qualified professionals, you can help to ensure the safety of workers and the public. Remember that electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical accidents. Staying informed about the latest codes and standards, using qualified personnel, and implementing proper safety practices are all essential for maintaining a safe electrical environment.